Good afternoon, everybody. Thank you so much for joining the next webinar in the CAVE series of webinars that we have put out to hopefully help you with ideas about not only bringing curriculum into your online courses, but also looking now at virtual reality, which we've touched on a little bit in some of the other webinars, but we wanted to have one exclusively dedicated to that topic. So I want to introduce my colleague, Dr. Jeff Bertrand. He's been the Director of Visualizations for the Center for Workforce Development for a number of years. He and his team of graduate students and a full-time colleague now are helping us to create all of the simulations that you see. So Jeff's going to talk with you today about how to potentially build these, put them in your classrooms, and then we're always interested for you to reach out to us for how we can support you as you need help in these areas. So we will do a survey at the end. I'll put it in chat, and we will also have it appear on the screen once the webinar is over, so you can quickly access it. And then we'll also send it in an email. Just your feedback is very important to us as we try to improve the series and also gain some insight from you on other topics that we might be able to share. So I'm going to turn it over to you, Jeff, and then I'll come back and help him with some of the Q&A. Just feel free to put that in the chat as we move along, and we'll be able to answer those questions. So, Jeff.
Thank you very much, Rebecca. That's a great introduction. So again, my name is Jeff Bertrand. I'm the Director of Visualizations for Clemson University Center for Workforce Development. And my primary responsibilities are building out our virtual simulations to put on our Educate Workforce platform. But in addition to that, we also conduct some research studies, kind of looking at the efficacy of using virtual reality in education. So throughout the talk today, I'm going to pause a couple times for a little Q&A session, and I'll ask a focus question. So if you want to put your responses into the QA part of Zoom, I'll take a look at those during those times. So let's go ahead and get started. So for the agenda today, we're going to define what VR is. This is going to be mostly from our perspective. So we'll go on a little VR tour of some of the simulations that we've developed in the past. And we'll classify those into different types and genres. We'll also answer why we want to use VR. And we'll talk about some of the advantages and disadvantages of using them. And this section really follows nicely from the previous webinar videos. So if you haven't checked those out, I highly recommend doing so. And in the last section, we'll step you through what the process is for building one of our virtual simulations. So first off, what exactly is virtual reality? So in virtual reality, we're trying to simulate an experience. So for instance, a lot of times lab time is very limited. So what we can do is build out the lab activity in virtual reality so that students can practice it before coming to the lab. We can also build workplace environments. So a lot of times it's a problem sending the students out on the field trips to real workplaces. So we could simulate those in virtual reality to give them some extra practice. So there's been quite a bit of research on the efficacy of using virtual reality in education. So I'll be talking about that throughout the talk. And I think the most important aspect of virtual reality is the interactivity aspect. This is having the students actively engaged in the content, which really increases engagement with the material. So looking at some of our virtual simulations that we've created over the years, we primarily focused on the automotive and aviation domains, but recently we've been branching out into different areas such as robotics, photonics education, and even underwater ROV, remotely operated vehicle simulations. So in addition to that, we also conduct our research studies. So we want to see what the effects are, what the learning gains are in using virtual reality. But we can also study different effects that aren't possible in the real world using virtual reality, and I'll touch on that here shortly. So broadly speaking, we could classify virtual reality into different types. So the first type is going to be desktop VR or non-immersive VR. So this is where students don't need any special equipment. They can just access the simulations directly in their web browser. They just need a regular laptop to access them. But when people mention virtual reality, they usually think of immersive virtual reality, where you're wearing a headset and using hand track controls to completely immerse yourself into a virtual environment. So I'll touch on a couple examples of where we use immersive VR in our simulations. And also talk a little bit about augmented reality. So we don't do too much AR in the lab yet, but we're looking at doing some research studies using augmented reality. So looking closer at what desktop virtual reality is. So on the right here, this is our breadboard activity where students are building up a circuit on the breadboard, and they use a multimeter to measure the current going through it. So in this case, you don't need any special equipment. All you need is a mouse and keyboard to, for instance, turn the knobs there on the multimeter or grab the probes and move them around. And since these are browser-based, we can widely distribute them fairly easily, which makes them very scalable. So like I said, almost all our simulations are targeting desktop virtual reality so that students have an easy way of accessing these simulations. And we try to make them as modular as possible. And usually they only take about 10 to 15 minutes to complete. So if students want to come back and try them out, they don't have to spend too much time going through other virtual simulations. So these desktop virtual simulations are built on top of WebGL. So almost all modern browsers have WebGL built into them. So this allows us to render our virtual content directly in the browser without the students needing to go out and downloading plugins or anything. So that makes it fairly easy for us to distribute these virtual simulations to the students. So for the implementation on Educate Workforce, so the educational content is divided into different modules, and each module usually has a video lecture, a VR, and assessments. So the video lectures are good for, explaining the theory behind what we're trying to teach in the virtual environment. And then the VR lets the student practice it on their own time. And so again, we're primarily targeting technical colleges and four-year institutions. But we also build some of these simulations out for high school students as well. So here is an example of an immersive virtual simulation. This was a research project where we were just looking at different levels of fidelity in virtual reality. So here you can see the student is fully immersed in the virtual environment, and they're performing natural interactions with their hands out front. So we're trying to simulate what it would be like in the real world, right? And later on in this talk, I have an example of a virtual simulation that would only work in an immersive environment. And so we also do a lot of demos. So immersive virtual reality is great to take these simulations out on the road. So when we show it to kids, they really love getting into the virtual environment. It really keeps them actively engaged. So here's an example of augmented reality. So here you can still see the physical world around you. But what we've done is attach a virtual object to the tabletop in that case. So you're looking at it and looking at it from different angles. So you might have used augmented reality yourself. So for instance, there's some apps out there that let you place furniture in your room so you can see what it would look like with that piece of furniture in there. So next I want to talk about some of the advantages of using virtual reality. So I think the most important one is interactivity because it promotes active learning. So students learn by doing. This is a pretty common thing that you find in the literature. And it really increases user engagement. So students have to really focus in on the task in order to learn about it, which increases motivation and self-efficacy. And again, this is really tied to the previous webinar series, so definitely check those out. And so The VR simulations are also repeatable, which really helps with retaining the information. And what we can do is randomly generate scenarios. So if the student comes back to a virtual simulation, they'll see a completely different one. And I'll talk about that here shortly. And again, these virtual simulations are highly accessible. So all you need is a laptop or a computer connected to the internet. So you can run these simulations at any time and anywhere. So some more advantages of VR. So we can do 3D visualizations. So this example on the right, we could give you X-ray vision into what it would look like with the electrical flow through an aircraft. And in this case, this is immersive simulation. So the student's using a headset to look around. That helps with making a connection between the material and the real world, right? And also there's the safety aspect. So there's no problems with potentially damaging any equipment or other people. And then we could also do scaffolded learning, which I'll talk about later. And with these simulations, you can get instant feedback, right? So some of the disadvantages of VR, though, is technology acceptance. So I think one of the main issues is instructors and students don't want to learn a new technology. So what we try to do is keep the simulations as simple as possible and as accessible as possible. So all you really need is a web browser to access the simulations. Understanding the best practices. So for VR, since it's a fairly new field of study, the best practices are constantly changing. So we have to kind of stay on top of that when we're designing these simulations. Also, we could run into technical issues. So since we're designing these simulations to run on such a wide variety of hardware, it's sometimes difficult to account for all of it. So for instance, if we build a simulation that might not run well on a Mac, we'd have to figure out why it does that. So sometimes we run into those technical issues that we have to mitigate. All right, so I'm going to take a little break here and ask a focus question. So what are some of the other advantages and disadvantages for using VR as an educational tool? So if you have any questions or anything, I'm going to take a look at the Q&A.
I don't think we have any yet, Jeff, but everybody feel free to go ahead and ask questions. We won't wait till the end. And specifically, if you have answers to Jeff's question about the advantages and disadvantages for using VR as an educational tool, and hopefully he can negate some of your thoughts around disadvantages.
Yeah, so I see some of the Q&A over here. So the top question is, how do we contact you about creating simulations? So if you send us an email at cucwd@clemson.edu, it's the best way to get in contact with us. We always like to partner with other institutions and to build some of these simulations out. The next question is what kind of software we use. So we primarily use Unity 3D to build these simulations. And at the end, I'm going to talk about our process for developing. So I'll get into more details shortly. Another question is, how do you design the simulation for a particular lesson? And do you use a storyboard or some other templates when you get started? So typically with our virtual simulations, we're trying to emulate what the student would do in the real world. So for example, one of our simulations is the student is fabricating a fluid line fitting. So there's a pretty good step-by-step process that they have to follow. So that's a good candidate for using virtual reality to give the students some practice before getting into the lab. Another question is, how does VR work with tablets? That's a good question. It's kind of hard to do. So if we wanted to build applications specifically for like an iPad or an Android-based tablet, we'd have to build that out for it. With WebGL, we can run these simulations directly in the web browser, but there's some issues with running them on mobile hardware like that. So that's one of the things that we're looking into now. All right, good. And the last one here, it says it allows students to make mistakes in a safe environment. Yeah, that's perfect. That's definitely one of the main advantages of using VR. All right, so for this next section, I'm gonna kind of divide some of these simulations out into different types of genres. This is more specific to us. So for instance, if we say we want to design a procedural simulation, that's what the term that we'll use. So for instance, a procedural simulation takes the user step by step through a process. There's not a lot of branching or anything that they can do. They have to complete one step after the other. But we also have other like nonlinear simulations where we let the student loose in a virtual environment and they have to complete a certain task. We also have simulations that are specifically for practicing a skill, which I'll show here pretty soon. And we also have serious games where we try to implement some gamification aspects into the simulations. All right, so here is an example of a procedural simulation. So this has taken the user step by step through the process of fabricating a preform to use in optical fibers, right? So they've built this preform in the previous simulation and they put it into the draw tower here. And this is taking the user step by step through the process. So this is an example of a guided practice phase where the student can only complete one step at a time. If they try to complete a different step, then it doesn't work. But during the exercise phase, students have to repeat what they just learned without any guidance, right? So if they accidentally do something out of order, we give them an error message. Now, if they forget how to do a step, then we do have a hint system that gives them an idea of what to do next. And again, you can safely make mistakes in VR on potentially dangerous and expensive equipment. So some of the equipment that we modeled here is multi-million dollars, so you don't really want to mess those up. So here is another example. I kind of touched on this before, but this simulation is taking the user step by step through the process of fabricating a fluid line for an aircraft. So again, the students interacting with different elements on the screen. So they could put the line into the vise and they interact with the vise to clamp it. And then they can use a hacksaw to cut the end off. And so we have some interaction metaphors where the student can just click and drag and move up and down to kind of simulate the action of using a hacksaw in that case. And so here is an example of a nonlinear simulation. This is our manufacturing safety simulation where the idea here is the student assumes the role of safety auditor and they're walking around this factory environment looking for different safety hazards. And once they find a safety hazard, they tag it. So in this case, we let them completely roam around this virtual environment all on their own. And this is the simulation I was talking about where we can randomly generate scenarios. So for instance, if they come back to the simulation, these hazards won't be in the same place. And we can also set it up to where we start out fairly easy and fairly obvious hazards. So the oil spills are pretty easy to find, but we can have more subtle and more difficult hazards as the user becomes more familiar with the simulations. And so here's another example of a nonlinear simulation. So risk assessment field engineers need to be able to go out into the field to look at, in this case, when they're looking at roofs to survey any kind of wind damage that might occur. But it's kind of expensive and logistically an issue sending students out on field trips. Right? So in this virtual simulation, we allow the student to walk around and in the actual task, they take pictures of issues that they might find in the field. And then they can take notes and generate a report at the end. But again, this is another case where it's non-linear. Student has complete agency on what they're trying to do. And here's an example of a practice skill simulation. So I actually did this in the real world. So towing an aircraft is very difficult to do. You don't want to make mistakes. So for instance, in this case, if you see the red strut line down there at the bottom right, if you go beyond that strut line, you'll break the axle or the strut, and it's going to be a very costly mistake. So it's better to do this in virtual reality first. And this example here, so the real challenge when towing an aircraft is really rotating it into the right spot. So what you have to do is kind of drive out in front of that pivot to rotate the aircraft, which is, it's hard to explain and intuitively without being able to practice it on your own. So that's kind of why we built this virtual simulation. And so recently we've partnered with Mate ROV. They have an annual competition, worldwide competition between teams that build remotely operated underwater vehicles that compete in doing some certain tasks. But since COVID canceled pretty much everything this year, we wanted to come up with a different way of still allowing the students to practice piloting an ROV. But we wanted to make it a competition as well. So this simulation is employing some gamification aspects. So the task here is they're flying this ROV underwater, and they're trying to neutralize this type of starfish that's detrimental to coral reef ecosystems. So the idea is to get as many starfish as they can within a certain amount of time. And so in this case, we've implemented a leaderboard where students can compete with others to try to get as many points as possible. So this has given them a chance to practice flying the ROVs, but also learning about some ecological issues that are affecting the oceans. In addition to some of our educational simulations, in this one, we've partnered with the School of Nursing to develop a simulation to simulate the effects of Alzheimer's and other comorbidities that you might have if you're elderly. So here we're trying to induce empathy into the caregiver so that they can see what it feels like to have Alzheimer's and to be able to complete simple tasks. So in this simulation, the user is using a head-mounted display. And in this case, we have, it's hard to see in front of you. We have a little macular degeneration issue with your eyes, which makes it hard to complete a task. And also they're listening to like white noise, which makes it very difficult to focus on the task that we give them in the simulation. So this is a good example of that would only work in an immersive virtual environment, right? This doesn't work as well if you are just doing the simulation on just a regular desktop monitor, right? And some simulations don't really fall into a category. So this is an example of a hybrid simulation. This is our articulated arm robot. So this has aspects of visualization. It's kind of a nonlinear task, but there's also kind of a procedure. So here's the like 3D working envelope that the student needs to know about. So this gives them an idea of what that looks like. And they can manipulate the robot arm around and see how the center of gravity changes with their manipulations. And then they have a task where they have to pick up an object, place it on the conveyor belt, which will come up here shortly. So again, you could fly around these virtual environments, or the camera will snap to where it needs to go. So here you can see the student picking up the box and then placing it on the conveyor belt. All right, so here's another focus question. So what are some other areas where VR would be a beneficial learning tool? So I'll check the Q&A and see if there's any other questions. Yeah, so there's a couple good responses in the Q&A. So distance learning environments, yeah, especially the desktop VR simulations where students can just use a regular laptop to access them. It's very good for distance learning. VR can be good for explaining mathematical theories, especially when you show what happens. For instance, one of the ones that we're going to be working on next in robotics is where we have like a mathematical principle, and then we'll allow the student to interact with the robot to see how that principle is affected. So that would be a good area where mathematics would be good in virtual environments, as well as physics too. That's a good point. All right. So I'll go ahead and go on to the last section here. So next I'll talk about how we develop a virtual simulation. So I'll use one of our latest ones called the MCVD lathe. And this simulation takes the user step-by-step on how to fabricate this preform in order to make fiber optic cabling. So our development process can be broken down into a pre-production, and a production, and a post-production phase. So during pre-production, we usually try to brainstorm ideas of what would be the best use of VR. So we start out by building these task analyses to figure out what the student should be doing in the virtual environment. And during production is when we start to build out what you're going to actually see on the screen. So we go through visual asset creation pipeline. And at the end, I'll talk about some of our web deployment and how this looks in Educate Workforce, and also touch on some of the research studies that we do. So a typical virtual simulation will have a subject matter expert that will have domain knowledge of what we're trying to convey in the virtual environment. We also have instructional designers that help us focus in on what we should include and how we can attain the learning outcomes in this simulation. And we also have human factors and industrial engineers that help us with figuring out how students should interact with the simulations and how focusing on some of the usability aspects in the simulations. And finally, we have our virtual reality developers who actually program out what you're going to see and do in the simulation, and the artists focus on what the visual assets will look like. So during pre-production, I think the most important aspect of it is defining the learning outcomes. So what should the student know by the end of the simulation? And this can be somewhat difficult to find out. So we do some industry and educator surveys. So we reach out to others, try to figure out where the gaps are in students' knowledge. So where can VR be helpful for filling those gaps? And during pre-production, we want to really outline the scope because in virtual reality, we can design pretty much anything. So this is a good time to really scope down what we should include in the virtual environment. And here we also want to figure out who our target audience is. We want to know what kind of skills they already have coming into the virtual environment and how can we improve those skills when they go through the simulations. So here's what a task analysis looks like. So in this case, we just broke down all the steps that you need to do in order to complete the task of fabricating this preform. So again, this is a good point to do some scoping down. So we don't need to include every single little aspect in the virtual environment. We just need to focus on what the most important aspects are. And we also take a lot of videos and pictures. This is helpful for us to get the look and feel of the virtual environment so that we can replicate it and make it look correct. And so we also do a storyboarding phase. Basically, we take some of the pictures that we took before and try to think about different camera angles and kind of some of the instructions that we should include during each step. And this is where we try to figure out like what kind of interaction metaphors we should include in the simulation as well. So during the visual asset design process, we usually try to go out and download CAD models but a lot of times those CAD models are too complex. So they don't render very well on low-end machines. So if we do go out and download the CAD models, we usually have to go through a retopology phase, where that basically just means we are simplifying the mesh but retaining the details. But in this case, we didn't really find a good lathe model, so we started from scratch. And when we do that, we usually use a blender in this case, where we use a box modeling technique where we just rough out the main shapes, and then we just kind of keep refining it as we go along. So here's what it would look like in Blender. Like I said, we kind of just rough out the shapes. We want to keep the shapes as simple as possible, just to keep the polygon count low for optimization purposes. Once we have our model complete, we bring it into Substance Painter. And this is a good program to do physically based rendering techniques. So for instance, we would model the different parts. We would say like this part is metal and this part is non-metal, and we would give different values to those textures to really make sure that the lighting information is consistent when we bring it into Unity. We also do some texture aliasing at this point. This is basically where we just combine different parts of the mesh into one, so that the renderer doesn't need to render all these other images at the same time. So once we have our models textured and painted, this is when we bring it into the Unity game engine. And at this point, we set up our scene just by placing the objects in the scene, trying to set up the scene hierarchies. Here, we bake out the light maps. So it's better to bake the lighting information into textures so that we don't render the lighting in real time. So that's another optimization step that we take. And during this phase, this is where we start to define what kind of physics and what kind of collisions we should think about. Like for instance, the chucks there, we want the student to be able to manipulate those chucks. So we have to write scripts that respond to the user input and then communicate back to the scenario generator. So a lot of our simulations follow this scaffolded learning approach that I kind of touched on before. So in this case, we started out with a terminology phase that just went through each part of the machine and defined what that part did, how you can interact with it. And then during the guided practice phase, again, this is where we just take the user step by step through the whole process. So again, they can't do any steps out of order, so they learn it the correct way. But then at the end, we have an open exercise phase where they have to repeat what they just learned. So that this really helps with retaining the information or retaining everything that you need to know about this activity. So once we have our simulations built, we go through an extensive stress testing phase. We're trying to find any kind of errors or bugs the simulations might have. So we might share the simulation with small focus groups just to kind of figure out if there's anything that we're overlooking. And then at the end, we want to conduct our controlled research studies. This is an example of one of the ones that we're working on right now, where we're trying to figure out what the learning gains are when you use virtual reality as compared to watching a video or just looking at slides. So for our Educate Workforce deployment, so again, this is our online platform that houses our materials. So you can see what the virtual environment looks like on the page. A lot of times we want the student to run the simulation in full screen mode. So there's instructions in there that will blow it up. And usually instructors will pick and choose different modules to put into their courses. So they don't need to do every single part in the module. They can just pick and choose what they want to put into their courses. And again, these simulations are just simply embedded in an iframe. So it's rendering directly in the web browser. So here's a demo video of the MCVD lathe. So this is, again, the guided practice phase. So here the student's turning on the rotation. And then the next step highlights, and they click on that. And they can turn on the pilot light. And then they can turn on the burner. So again, this activity is kind of dangerous to do in the real world. So it's a good use of virtual reality to get some practice before going into the real lab. And again, like during the exercise phase, they can make mistakes and learn from those mistakes without breaking any equipment. All right, so the key takeaways from today. So VR can be a very valuable tool for education. We've had quite a bit of success with our virtual simulations, but there's such a broad range of possibilities. So we really like to work with instructors to figure out what the best use of virtual reality is. So that's kind of what we really want to focus on coming up. So, all right. Okay, so that's all I have for today. We've got plenty of time for questions, so if you want to go ahead and put those into the Q&A.
Yeah, so thanks everyone for joining today. Definitely want to use this time just to ask some one-on-one questions of Jeff. I know a lot of you know him, and you know he's very willing to help you with anything that you need for your classrooms or other just questions about setting up labs or use of this information that he's shared. So any thoughts that you'd like to put in Q&A, he'll be happy to answer those.
So I see a couple good ones. So this question is, how long does it take to develop a virtual simulation from start to finish? So that really depends on the complexity of the task. So some simple simulations we could do within a month or so. But that's kind of benefited from our use of a consistent architecture. So we've been developing this architecture for a while now. That makes it really easy for us to just plug and play different aspects into the simulation. So as far as turnaround time, it can be really fast. But for a more complex simulation like the MCVD lathe, that took us probably around 6 months or so altogether. Another thing that you have to keep in mind though is we do multiple projects at the same time. So if we dropped everything focused on one simulation, it would definitely be a lot faster turnaround time. But here we have to take into account the other simulations that are in the pipe and other research projects that we're trying to complete as well. So that sometimes adds a lot more to the development time.
Other questions for Jeff? I think you've got one other one, Jeff.
All right, so the other one here is, how are you tracking that the learner is understanding what presented to them in the virtual simulations? Do you conduct surveys or follow-ups or track analytics? So yes, we definitely do that. So we do the controlled research studies to really make sure that we are learning about, figuring out what the learning gains are. So that's why we want to do specifically controlled user studies. But we also have like post-survey questionnaires for all these modules. So we can definitely do analytics that way. But again, I think one of the best ways of determining what the learning gains are is in a controlled study.
And then I see the next one from Richard, and I can probably speak to that. Is there a cost to the educational institution for simulations, or is it covered by the grant? We have a learning management system called educateworkforce.com. All of the virtual reality simulations are housed there. Once Jeff and his team have created those, they are embedded into curriculum that we have as part of Educate Workforce. And we do charge a nominal fee to access this curriculum. We've got a structure where you can choose multiple modules or one or two that would best suit the needs of your course. But Richard and others, I can let you know right now that we have a robotics course that we are currently piloting, and we need feedback on that course so that we can improve it and update it. So that is at the associate level. We'll also be having a robotics course that would be at the bachelor level that would be released soon. And then later we'll have one at the high school and also at the master's level. So all of these courses have virtual reality embedded in them, and they're designed that way because it is difficult, we found, just from some of the survey data that we have received and just other research, that it is a little more difficult for students to learn just with virtual reality as a standalone tool. So we have, even with the guided practice pieces that Jeff went through with you, we have curriculum that supports that. So we are doing those robotic pilots as supplemental materials to courses that you may already be teaching. And then we'll have some pilots on our aircraft maintenance courses through the FAA Part 147 curriculum. General if you're familiar with that, is what we'll be piloting in the fall. So if those are of interest to you, please reach out. We can share any of this material with you so that you can review it, kind of look through and see what modules you might like to pilot with your students. And again, it's meant to be supplemental material. It's meant to be used in a hybrid format, but knowing that a lot of our institutions right now, our partner institutions, are going through the same protocols that we are for COVID and learning in some hybrid formats. You can also do a large portion of that online. So please reach out. I'll put my email here in the chat. I've also gone ahead and put a link to the survey so that you can access that as well. But please reach out to me with any questions if you're interested in piloting any of the courses that we have on Educate Workforce. Other questions that Jeff can answer or I can answer?
There's another question about publishing the study that we mentioned. So that one we are just now gearing up to run. So we'll be collecting some of that data here probably over the summer months. So usually we target IEEE VR, but there's other conferences sometimes that we go for. Computer education is a good one. So yeah, those are the main areas that we try to publish our research in. Another question here is, what's the best way to view the library simulations? So on our website, we do have YouTube links to a lot of these simulations that you can check it out at any time. So if you just go to our website at cecus.clemson.edu/CUCWD, I think that's the main one. So that's a good place to check out some more of these virtual simulations that we've developed.
Okay. Thanks, Jeff. We really appreciate you doing this. We'll also be sharing this on our website, so a link will come out to you as participants. Feel free to share that with colleagues who have missed this, or anyone that you know who might be interested in learning more about virtual reality through the Center for Workforce Development. Again, the survey is in the chat. We'll send you an email link as well, and it'll pop up on the screen if you want to go ahead and take that now once we close. So again, thanks for all of the good questions and all of your participation this afternoon, and a huge thanks to Jeff for doing this for us. Have a great week. Thanks again.
Thank you.